So hello again, class. You're going here. So yeah, this will be the last podcast of Module 4, specifically class part 7 of Module 4. So I'll just share my screen, class. Yeah. Okay. So we are to continue class with the strength. Yeah. Strength of concrete. Okay. So supposedly class, again, we'll have a detailed discussion video about strength. So I'll just scan through it. No? So technically class, strength of concrete. So again, class, concrete kasi is strong in terms of compressive strength. Okay. However, it is weak in tension. Okay, so till date, class, no relation exists between compressive, tensile, bending, tsaka shear strength of concrete. Okay. However, it may be mentioned that the typically strength, tensile, and bending strength of concrete are 10 and 15% respectively of the compressive strength. So supposedly, class, again, ang pinaka strength kasi ng concrete class is compressive strength. So if we compare class yun nga, yung tensile tsaka bending strength to compressive strength, ganito lang siya. So tensile strength of concrete is only 10% of its compressive. As well as class yun dun sa bending niya, it's only 15%. Okay? Tapos in terms of shear strength naman class, so yeah, 20% lang siya. Nung yun yung actual compressive strength. Okay? Tapos there are certain factors kasi influencing the strength of concrete. So in terms of strength of concrete class, it's safe to assume that this is the compressive strength. Okay. So yun nga, number 1 class is yung size of the specimen. So madami to class up to ano. Okay. So second class is the type of stress situation that may exist. Yung size of specimen with regards to the size of aggregate, moisture condition, the air voids in the concrete, rate of loading, type of testing machine, okay? The type and age of cement, the cement aggregate ratio, type and size of aggregate, the degree of compaction, mixing time, and lastly class yung curing method, tsaka yung curing temperature. Okay? So technically class, meron tayong video about an introduction regarding the strength of concrete. So let's watch this now. Yeah, okay. So let's go to the strength. So here it is, class.
Strength of.
Yan. Okay, so let me just fix it. Yan. Oh gosh. Okay. So ito class yung intro niya. So this time class hindi niya diniscuss yung hindi niya diniscuss yung factors influencing. Anyway, tuloy natin.
Concrete. The quality of concrete is judged largely on the strength of that concrete. We all know that concrete is strong in compression but weak in tension. In most of the structural applications, concrete is employed primarily to resist compressive stresses. In the cases of concrete in tension or shear, the compressive strength is frequently used to measure these properties. Thus, we can say that the compressive strength of concrete is used as a qualitative measure for the various properties of hardened concrete. Generally, the strength of concrete is its resistance to rupture. It can be measured in a number of ways, such as strength in compression, strength in tension, strength in shear, and strength in flexure. These strengths of concretes are calculated by various methods which will be discussed in future videos. When concrete fails under a compressive load, the failure is essentially a mixture of crushing and shear failures. However, the mechanics of failure is a complex phenomenon. In general, the concrete in resisting failure generates both cohesion and internal friction. This cohesion and internal friction are related to a single parameter called as water-cement ratio. Besides, the strength of concrete is influenced by the following factors: ratio of cement to mixing water, ratio of cement to aggregate, grade.
So andito pala class, pero yung specify niya lang. Okay, so these are the following. This following These are the factors influencing the strength of concrete. Okay.
Reading, surface texture, shape, strength and stiffness of aggregate particles, and maximum size of aggregate. The water-cement ratio primarily affects the strength, whereas other factors indirectly affect the strength of concrete by affecting the water-cement ratio. We will discuss each factor one by one in future videos. Thank you for watching. Stay tuned. The best is yet to come. Kindly do like, share, comment your views, and finally don't forget to subscribe our channel.
Hindi niya discuss. Yeah, wala hindi niya discuss pala class. Anyway, class, okay, pasadaan na lang natin class, factors affecting, no? So technically, class, ang pinaka-bulk in terms of yung strength ng concrete sa testing to is yung size ng concrete. Okay? So supposedly, class, diba, ang ginagamit kasi natin in terms of yung compressive strength of concrete is yung concrete cylinders. Okay? So supposedly, yung concrete cylinders, class, eto. So na yun. Yan. Concrete cylinders class should always have a height equal to twice its lateral dimension. So kung ano man yung diameter ng cylinder mo class times 2, yun dapat yung height niya. Kumbaga dapat ganun lahat ng molds, yung mold natin, kung saan natin nilalagay yung concrete specimen. Okay? Ayan, ganyan lang naman. Tapos pag gagamit naman tayo ng cubes class, supposedly daw class if we are to use cubes, ang isang side natin class is equal to 150 mm. Okay? Yeah, yun lang naman. Tapos yun, again, class, meron tayo nung type of stress. So supposedly kasi daw class, concrete is supposed to be tested in uniaxial compression. So dapat pag uniaxial class, isa lang. Kumbaga kung nasaan lang class yung parang perpendicular lang siya class to the face of the concrete cylinder. Okay? Tapos ito, in terms of yung size ng specimen with regards to the maximum size of aggregate. Okay? So, general daw class, pag yung cubes yung gamit natin, So, ganun. Dapat class, pag yung aggregates natin class, diba nililimit natin yan sa 38 mm class. So, pag dalawang cubes, gamit tayo ng 150 mm. Okay. So, in terms naman class of moisture, supposedly moisture in concrete provides lubrication effect and reduces the strength. Yeah, okay. So air voids class form because of evaporation of water and entrained air. Water use is optimum required for the maximum. Yeah, strength of concrete becomes permeable and susceptible to deterioration. So rate of loading class supposedly, yeah, increase in rain. So strength of concrete increases with the increase in rate of loading. That normally class. Static loading test should be completed within 2 to 3 minutes. Okay. Tapos yung type of testing machine. So, dalawa lang yan class. It's either lever arm or lever press or computerized. Okay. So, yung type and age of cement class also matters. Same with the cement aggregate ratio, yung size ng aggregate, yung degree of compaction, tapos yung mixing time. So ang isa dito class is yung mixing time. So supposedly the strength of concrete increases will increase in mixing time up to 2 minutes. Okay, so beyond that class, wala na siyang effect. So curing method class, tsaka yung curing temperature. So higher temperature, the greater is the rate of hardening of concrete. So 10 hours of curing at about 90% of 90 degrees Celsius. Okay. So, summarize natin yun, class, no? Summarize natin yung na-discuss kanina. Supposedly, class, no? We are already at 4.11.2. The length of concrete. Okay? So, isa lang yung gusto nating malaman dito, class. No? Actually, class, concrete, no? So, it should be known that as concrete is weak. Okay, so, muna natin in strong. Strong in compression. Okay? But weak in tension. Again, class, no? Ang malakas sa tension, class, is yung steel. Kaya tayo nagkaroon, class, ng reinforced concrete. Kasi yan. Yung weakness dapat ng concrete, class, dun papasok si steel. Okay? Tapos meron tayong factors affecting, class. Meron tayong factors affecting strength of concrete. Okay. So, isa-isayin natin. List ko na lang. Isa lang. Kasi syempre, andyan yung size. Size of the specimen. This specimen. Okay. So, dalawa lang kasi yan glass, no? It's either prism lang siya or yung cylinder. Actually, cylinder class or yung cube. Okay. So, pag isapang cylinder tayo, supposedly yung height natin. Supposedly, no, yung height ng ating prism or cylinder should be equal to 2 times yung diameter natin. Okay. Pag cube naman, class, ang sides dapat natin dito is 150 mm. Okay. Tapos in terms of relationship, class, supposedly, habang lumiliit, class, yung side, tataas daw yung strength ng concrete. Okay. So, second factor affecting the strength of concrete, class, meron tayo ng type of stress situation. Okay. Number 3, class, meron tayo ng maximum size of aggregate. Size of aggregate. Number 4, moisture condition. Okay. Number 5, class, is yung air void. Okay. Number 6, rate of loading. Okay. So, 7, class, medyo halfway na tayo, is yung type of testing machine. Dami, no? Type of testing machine. Ayan. Tapos number 8, yung type and age of cement. So, type. Tapos yung age of cement. Okay. Number 9 naman, class, yung cement aggregate ratio. Cement aggregate ratio. Tapos 10, class, meron tayo ng type and size of aggregate. Type and size of aggregate. Okay. Number 11, class, in degree of compaction. Of compaction. compression. Okay. Second to the last class is yung mixing time. Ito yung pinaka-bulk ata ng factor eh. Okay. Tapos lastly class, syempre yung curing method tsaka temperature. Curing method and temperature. Okay? So yan class, we have 13 factors affecting yung strength ng concrete. Okay? So dire-diretso na tayo class. So after the factors class, we're to discuss yung test for concrete. Okay? So technically class, ito test natin siya in terms of yung compression, strength niya, compressive strength. Okay? Yung flexural. Ay, dami pa pala. Yan, yung tension, tas yung flexural. Okay? Tas isa pang parang durability or hardness test. Okay? So, 4, something ganun. Okay? O, yan. So, in terms of yung compression test class, again, yung test na to class, supposedly yung course aggregate natin is up to 38 mm. Okay? Tapos, yan. So, meron ulit tayong video class discussing para mas mabilis. So, supposedly lang class, yun, no? Gagamit tayo ng cylinders na 150 mm diameter by 300 mm height. Okay? Tapos gagamit tayo ng at least 3 specimens class. Tapos, ito yung formula natin class ng compressive strength of concrete. So, supposedly class yung load at failure over yung cross-sectional area ng specimen natin. Tapos meron tayong table dito class in terms of yung permissible tolerance ng compression test. So, supposedly class na test na natin yung cylinder in terms of ito. So i-test natin siya class sa 1 day, 3 days, 7 days, tapos 28 days. Meron lang tayong leeway class na number of hours. Pag lumagpas na doon class, in a way, medyo hindi na credible yung test results natin. Okay? Tapos, yan. O sige, doon muna tayo. Plus saan natin i-discuss tong paano natin interpret yung test results. Okay? Okay, class, ito yung video discussing yung procedures and all. Procedures, saka yung specifics ng compressive stress of concrete.
Compressive strength test on concrete. The compressive strength of a concrete is defined as the ability of the concrete to withstand specific compressive forces. Compressive strength of concrete depends on many factors such as water-cement ratio, cement strength, quality of concrete material, quality control during production of concrete, etc. Generally, the specimens shaped in cube and cylinder are used for testing the compressive strength of concrete.
So, in a way, class sa kanila, dalawa. It's either cube tayo or cylinder, no? Pero sa atin, class, more on cylinder tayo. Philippine standard. Okay. So, again, class, yun ang given. No? Kung ano yung diameter, class, twice ng diameter, yun dapat lagi yung height. Yan yung specs natin dito sa Pinas.
The standard size of a cubical specimen is 150 mm into 150 mm into 150 mm, while the cylindrical specimen is 150 mm in diameter and 300 mm in length.
So, ito sa atin, class, yan yung standard. Pero more or less, pwedeng kahit hindi ganyan as long as whatever the diameter, class, will be twice of it is the height. So, depende dun sa mold mo. Okay?
Generally, the fresh concrete is prepared according to the required grades and the respective mix proportion. Once the fresh concrete is prepared, the inner surface of the mold is greased to avoid sticking of concrete. The prepared fresh concrete is then filled in mold in 4 layers. After filling each layer, tamping should be done for 35 times for cube and 25 times for cylinder use.
So, dito sa atin, class, no, 25 times, tapos 3 layers lang tayo. Okay?
Using a standard tamping rod. Once the mold is filled, level of the top surface with a trowel. After a day, the mold is removed and the specimens are dropped into the curing tank at a standard temperature of 27 plus or minus 2 degrees Celsius. After 7 days, the specimen is taken out of curing tank and dried for a while. Then, the specimen is placed on the compression testing machine. The cube specimen is just placed on the bearing plate, while for cylindrical specimen, it is placed vertically. The instrument is adjusted such that the plate touches the top surface of the specimen.
The load is applied gradually over the specimen at the rate of 140 kilograms per centimeter square per minute. The load at which the specimen fails is noted. Thus, the characteristic compressive strength is calculated from the ratio of load and the area. The test is generally done with the help of 3 specimens and tested for 7 days, 14 days and 28 days. Thank you for watching. Stay tuned. The best is yet to come. Kindly do like.
So again class, yun yung end nun, no? So technically, ang discuss doon sa video class is yung testing. So i-discuss ko class, paano yung interpretation ng test results natin. Okay? Supposedly class, yeah, meron lang tayong given. So hinugot ko dun sa table 4.1 natin, no? So for a given mixture class of, or mixed proportion of cement class, meron tayong supposedly compressive strength. So gagamitin natin yan dito, no? Okay? So technically class, meron lang tayong criteria for a job specification. Meron tayong criteria class para masabi natin kung pass or failed by batch. Okay? So dito class, ang galawan natin is by batch. Yun yung ipapass or fail natin. Hindi yung individual test. Okay? Baka kung titignan nyo class from the test a while ago, class, dapat a minimum of at least 3 specimens tayo. Kasi class, yung average nun, yun yung i-judge natin. Hindi yung individual strengths. Okay? So parang minimum kasi yun, 3. So yung 3 specimens na yun, result of 3 specimens, i-judge natin class. Thus, we are to decide kung pass or fail yung batch. So yung batch yun class. Okay? So ano yung basis natin class nung failure? Ito, meron lang tayong dalawang criteria. Dalawa lang class, no? Okay? I-edit ko yun. Nalis ko yung pangatlo kasi, yeah, redundant eh. Okay? Ano yung first criteria natin class? Dapat the average of the 3 consecutive tests should equal or exceed the specified strength. So ano yung specified strength natin class? Depende kung ano yung mixed proportion natin. So for class A concrete, specifically class 1 cement, 2 sand, 4 gravel, dapat 21 megapascal. Ito class yung minimum natin. Kasi nga, di ba sabi doon sa first criteria class, should equal or exceed. Okay? So letter B criteria natin class, second criteria natin, no single test should fall below the specified FC by more than 500 PSI or 3.45 MPa. So kung ano man yung specified class, dapat wala dun sa law, yun, mas mababa siya by more than 500 PSI. Okay. Tapos kapag ang specified test naman natin class or yung specified strength natin is more than 5,000, dapat 10% dun. So technically, ganun din naman. Kumbaga pag nag-5.5 lang yan, hindi na 500 class, 550 na. Okay? Tapos again, class, keep in mind, it is important to understand that individual testing below FC does not necessarily constitute failure to meet specification requirements. When the average of tests on a job to be required, the probability that individual tests will be less than the specified is about 10%. Okay, it's accounted for the acceptance of criteria. So again, class, yan dun na yun. Sa criteria na siya, class. So kaya average yung kinukuha, hindi individual testing. Okay? So if ever man na ever man nag-fail lahat, class, hindi naman matik na ganun. Sometimes, class, human error yan. Okay? So, or yung failure dun sa testing. Okay? So again, class, i-summarize natin for, para mas, legal. So we summarize that was what is discussed a while ago. So again, class, we have discussed about test of concrete. Test of concrete strength na lang. Mabilis. Okay. So unahin natin class again, di ba, inuna natin yung compression test. Test. Okay. So compression test natin class is known as yung compressive strength test. Compressive strength test. Okay. So ano yung specs natin class sa compressive strength test? So gagamit dapat tayo class ng cylinder. So, ito class, no? So, ang test specimen natin class is cylinder. Okay. Tapos, ang dimensions nila class is 150 mm diameter. Okay. Tapos, 300 mm height. Okay. Or strictly class, dapat yung height is equal to twice nung diameter niya. Twice nung diameter. Okay. Tapos, again, class dapat. Yan. So, at least or minimum tayo class of 3 specimens. Okay. Preferably class at 28 days. 28 days dapat tayo kasi yun yung maturity ng concrete. Okay. Tapos again class, yung cylinder na yun class 3 layers. Tamp 25 times. Okay. Tapos meron tayong formula. Again, ang pinaka-formula natin class. Strength of concrete is equal to yung maximum load. All over class yung cross-sectional area. Cross-sectional area. Okay? So preferably class in terms of naka-Newton tayo dito. Tapos millimeter squared tayo dun. Okay? Para ang labas class naka-MPa. Okay? So dapat megapascals tayo dito. Okay? Tapos meron tayong job specification class. Kumbaga paano natin ma-assess class of pass or fail. So meron tayong tinatawag class na criteria. So dito natin i-compare class yung results. Okay? So dalawa lang yan class. Number 1. Dapat class yung average strength ng tatlo class should be equal to, greater than or equal to yung specified. So yung specified class, again, kukunin natin dito sa table 4.1. Depende sa mix yan class. Yan. Okay. Dalawa lang yung criteria natin. Second criteria natin class, dapat yun yung specified. Yung specified strength natin class, no? Minus yung strength ng either of the three. So 1, FC prime ng 1, 2, or yung 3, no? Okay. Should be less than or equal to 3.45 MPa. Okay? Or, yun, yung 0.1 nung F prime C if i-read natin to. If F prime C is greater than yung 35 MPa. Yan. Yes, bakas. Kasi dito class, no single strength test should fall below the specified FC by more than. So dapat kasi yung difference nung specified FC tsaka yung kung ano man yung result mo, so either 1, 2, or 3, should not be more than. So dapat less than 3.45 MPa. Okay? Tapusin na natin class. So with this class, pwede na nating sagutan yung example 4.3. Okay? So example 4.3. So the problem states that given on the table actual data from compressive strength of concrete cylinder. So ano yung kukunin natin class? Determine the compressive strength of each cylinder presented it assess if the batch passed or failed. Okay. Tapos ito yung given natin. So class A concrete tayo. So, class A concrete. Okay. Class A concrete, tapos concrete cylinder daw tayo, class. So, kung titignan nyo, class, meron tayong 150 mm by 300 mm cylinders. So, ito yung specimen natin. Okay. Ano pa yung given, class? So, yun na lang naman. So, ang record natin, class, ano daw yung strength of each concrete. Okay. Yan. Tapos, assess. Batch. So, titignan natin, class, or pass or fail. Okay? So, unahin natin, class, yung una. So, kukunin daw natin, class, yung strength ng yung tatlong cylinders. Okay? So, ang galawan lang natin dito, class, syempre, yung concrete cylinder. Okay. Tapos, ano yung maximum load nila? So, maximum load. Okay. Tapos, syempre, dito mo na makukuha yung strength nila. Okay. So, meron lang tayo tatlong 1. So, concrete cylinder 1, 2, tapos 3. Yan. So, dito, class, again, ang unit natin dito is kilonewton daw siya. Okay. So, dito, class, gusto natin MPa na siya. Yan. Okay. So, working formula muna tayo, class. So, ano bang working formula natin? Diba? From yung previous class, diba? Ito. So, FC prime class equal to, so yung max load. Okay. All over class yung cross-sectional area. Yan na. Para hindi na madami. Okay. So, again, class, since alam na natin na cylinder siya, tapos yung cross-sectional area niyan, so yung max load, all over class yung area. So, alam natin cylinder, so bilog. So, pi over 4. Gamitin na natin yung diameter, class. So, 150 squared. Okay. So, kung titignan nyo, class, ang given natin sa maximum load is kilonewtons. No? So, dapat, class, ito, i-convert na natin. So, para ma-convert natin yan, class, i-multiply natin siya ng 1,000 para maging newton. Okay? Kasi kung titignan nyo, class, ang unit natin dito is magiging newton na siya. Ito is millimeter squared na. Okay? Para matiin natin, class, yung MPa. So, ito na yung working equation natin, class, no? Lagay natin yung maximum loads. So, yung maximum loads natin, class. Yan. So, meron tayo ng 373. 73.93. Again, naka-kilonewton yan, no? So, meron tayo ng 424.12. Tapos, meron tayo ng 315.26. Okay? Pwede natin makuha, class, kung ano yung individual strengths nila. Again, ito yung working equation natin, class, no? So, alam nyo na, class, yung calc function natin, class, di ba? So, again, working equation natin, class. So, yeah, tawagin na lang natin tong A. So, yun lang naman yung unknown, eh. Okay? So, yung maximum load, class, tawagin natin A. So, working equation natin, class. Okay. Equal siya sa A. So, again, itong column na to, tawagin natin A. Yan. So, yung A, okay, all over class yung 1,000 times 1,000 times 1,000 kasi kinonvert natin yung kilonewton to newton, di ba? Times over 4 tapos yung 150 squared. Ito yung working equation natin, class. So, yan na ipapasok natin dito. Okay? So, again, class, working equation is yung alpha A times 1,000 all over yung pi over 4 times yung diameter squared. So, 150 squared. Okay. So, i-calc natin class. Yung una is 373.93. Okay. So, dito class magkakaroon tayo ng 21. Block. So, 21.16. Okay. Yan. So, isa pa class, again, huwag natin pipindutin yung on, yung clear. Equal sign lang tayo. So, tatanong yung next na class. So, 424.12. Okay, so dito class meron tayong flat na 24. Okay. And class equal sign. So, last 315.26. Okay. So, meron tayong 17.84. Okay. Supposedly, kas kukunin natin yung average. Ito ko na lang ilagay yung average. Okay. Kasi yung titignan nyo yung unang criteria natin class. Kailangan natin yung average. So, ilagay ko na dyan class. No? 21.16. Plus yung 24. Plus yung 17.84. Okay. Divided by 3. So, ito na yung average niya. Flat class na 21. 21 MPa. Okay? So, with this class, nasagot na natin yung una. Diba? So, una class, ito na. Ito na yung first natin na sagot. Yan. Okay? So, ito lang yung A. So, yan na yung sagot natin sa A. So, i-erase ko na class, no? Listen lang natin. Yan. Okay. Tapos, ilagay ko na lang sa baba class yung average. Again, class. 21 MPa. Flat. Ito class yung average of the 3. Okay. Salisin ko lang class yung ito. Yan. Okay. So, goods na tayo class. So, letter B na tayo class. I-assess na natin kung failed ba yung batch or hindi. Okay? So, paano natin i-assess yun, class? Tignan lang natin yung criteria. Okay? So, i-compare natin siya sa criteria. Okay? So, di ba, criteria number 1, class, di ba? Supposedly, the class, yung average F prime C should be greater than or equal to yung specified. So, titignan natin yung table muna, class, no? So, ang given natin class is class A concrete. So, ang class A concrete, ang specified concrete strength niya dapat is equal to 21 MPa. Okay? So, kung titignan nyo class yung average natin, 21 is equal to 21. So, we can say class na pasok siya. Okay? So, verdict natin dito class is okay. So, pasok tayo class dun sa first criteria. Okay? So, dun tayo sa second criteria class. Yung second criteria natin class, diba, is yung dapat daw yung specified strength. So, yung 21. Okay? Minus class yung either F prime C 1, 2, or 3. Okay? Yung difference dapat nila class should be less than or equal to 3.45 MPa. Okay? So, hindi na natin class i-check yung pangalawa. Kasi 'di ba, it's either yan or yung isa kasi hindi naman lumagpas ng 35 yung ating specified strength. Okay? So, yan. So, check natin yung tatlo. Kailangan natin i-check yung tatlo class. So, unahin natin class yung FC1. Okay? So, yung F1C. So, yung 21 plus minus yung F1C natin. So, 21.16. Okay? Ay, diretso na natin class kasi hindi kasya. Okay. Shit. Hindi kasya class, no? Diretso na natin. Okay. So, ang gagawin natin class yun, 21 minus class yun, 21.16. So, equal yan sa, yan. So, kung titignan natin class dun sa F, yung cylinder 1 natin class, pasok siya. Kasi 0 point negative pa nga eh. Diba? Walang bearing class yung negative. So it is class, pasok siya because it is less than. Huwag na natin lagyan na equal to. So less than siya class 3.45. Okay? So with this class, gawin natin okay. Okay? So number 2 namang class, so minus 24. So titignan nyo, mas pasok po ulit kasi negative 3. Okay. Negative 3 is still less than 3.45. Okay. So kung titignan mo class, okay. Okay. Tapos class, siyempre yung last. So 17.84. Pasok pa rin. Okay. So titignan nyo class, meron tayong 3.16 which is still less than 3.45. So again class, ang verdict natin is okay. Okay. So anong conclusion natin class? So since ang conclusion, so ang conclusion natin class, since pasok sa dun sa dalawang criteria, pass. Pasado. Okay, pasado tayo. Okay? So check natin yung mga sagot class. So yan. So kung titignan nyo class na 21, 24, tas yan. Tapos chinek natin class dun sa dalawang criteria, criteria 1, criteria 2. So pasado. Meaning class, the concrete batch passed. Okay? So, tapusin na natin class. So ang second test natin class is in terms of flexure. Okay. So ang tawag natin doon sa flexure test class is yung flexure tensile strength test. Okay. So technically class, para mas mabilis na. And so meron tayong formula na para measure natin class is yung flexural strength or yung modules of rupture is equal to ito. Nakadepende lang siya class kung ano yung distance between yung line of rupture at yung nearest support. Okay. For clearer class, ito. Meron tayong video.
Share, comment your views, and finally don't forget to subscribe our channel. Flexural strength test on concrete. The flexural strength of concrete is an indirect method for measuring the tensile strength of concrete. The test is made on the beam of size 150.
Yan. So ang specimen natin class is yung beam, no? Beam with 150 height, 150 width, tapos 700
millimeters into 150 millimeters into 700 millimeters or 100 millimeters into 100 millimeters into 500 millimeters. Flexural strength of concrete is determined by either central point loading or two-point loading.
So dalawa yung class, no? It's either center point, meaning yung load linagay sa center, or yan, yung two-point loading.
The typical machine used for this test is shown on the screen. The bed of the testing machine is provided with two steel rollers of 38 millimeters in diameter. The rollers is mounted at the distance from center to center is 600 millimeters for 150 millimeters specimens and 400 millimeters for 100 millimeters specimens. The load applied through similar roller mounted at the top. In case of two-point loading, the rollers are spaced at 200 centimeters or 133 centimeters center to center. The concrete is prepared as per required grade of concrete and placed on the mold in layers and tamped 25 blows for each layer. After a day, the mold is removed, and the specimen is placed in the curing tank at a temperature of 27 plus or minus 2 degrees Celsius. Depending upon the requirement, the test specimen is removed from tank and dried at 14 and 28 days for testing. The specimen is placed on the rollers and centered with the longitudinal axis of the specimen. The load is applied at a rate of loading of 400 kg per minute for the 150 mm specimens and at a rate of 180 kg per minute for the 100 mm specimens. Finally, note down the load at which cylinder fails by developing cracks. Now, measure the distance between the line.
So ito na yung A class. Again, it is defined as the distance between the line of fracture to the nearest support. So whichever is nearer class, yun. So kung ano yung mas maliit dito class, yun yung value ng
Of fracture and the nearest support, Consider this as A. If A is greater than 200 mm for 150 mm and 130 mm for 100 mm specimen, then flexural strength or modulus of rupture, Fb, is calculated by equation. Fb is equal to P into L divided by Bd square. If A is less than 200 mm and greater than 170 mm for 150 mm and less than 133 mm and greater than 110 mm for 100 mm specimen, then flexural strength or modulus of rupture, Fb, is calculated by equation. Fb is equal to 3Pa divided by Bd square, where B is the width of the beam in millimeters, D is the failure point depth in millimeters, L is the supported length in millimeters, P is the maximum load applied to the beam in kilograms, and is the distance between the line of fracture and nearest support in millimeter. Thank you for watching. Stay.
Okay? So again, class, i-summarize natin yun. Supposedly, class, ang next test natin, class, is in terms of, so meron tayong flexure test. Flexure test, okay. So ang tawag sa test natin, class, is yung flexural tensile test. Flexural tensile strength test. Yan. Okay. So in terms of specimen, class, no? So ang specimen natin, class, again, is beam. Okay. Ang specs ng beam natin, class, is 150 mm height. Okay. By 150 mm width wide na lang. Wide. Okay. By 700 mm long. Okay. Saan yung specs ng ating specimen? Klaruhin natin. Beam specimen. Okay. Yeah. Tapos, ang mini-measure natin, class, is yung same. Ilagay na rin natin. So, 3 layers of 25 close. So, stamping niya. Okay. So, ang formula natin, class, again, ilagay natin. So, if A is greater than 200 mm, okay. Ang formula natin, class, is equal to, so yung modulus of rupture, modulus rupture equal to yan. So, meron tayo ng PL over B D squared. Okay. Tapos, class, kapag yung A naman natin is kapag yung A natin, class, is greater than 280, mali yung aking class. So, kapag yung A natin, class, is greater than 280 mm, less than dapat. Ayun ba? Wait, check na natin sa video. Mali lang yun. Okay. I-edit ko yun class, dapat 200. So, dapat A is greater than So, A dapat class is greater than 170 mm. Okay. But less than 200 mm. Okay. So, yung modulus of rupture natin class, modulus of AMR ko na lang, no? Will be equal class to 3PA whole over yung BT squared. Okay. Again, class, i-edit ko to. Dapat ganun. Ang range ng class is from 170 to 200. Okay. So, tuloy natin class. So, meron din tayong tension test class. Okay. This time, ang specimen natin class is made of cylinder. Same class, no? Ang diameter niya class is 150. Ang height is 300. Okay. Tawag sa test natin class is yung split tensile strength test. Okay. So, meron tayong formula class 4. Yun, yung split tensile strength test natin. Okay. So, panoorin natin class.
Then, flexural strength or modulus of rupture, FP is the maximum, it is the max channel.
So, ito na yung tensile tensions test natin.
Split tensile strength test on concrete. In the split tensile strength test, the tensile strength of concrete is obtained by applying a compressive force along the length of the concrete cylinder. The specimen used for this method is of cylindrical in size and dimensions of 150 mm in diameter and 300 mm in length. The instrument used for this method is the universal testing machine. The specimen is prepared in the standard manufacturing procedure and placed on the mold in layers and tamped using 25 blows for each layer. After a day, the mold is removed, and the specimen is placed in the curing tank at a temperature of 27 plus or minus 2 degrees Celsius. Depending upon the requirement, the test specimen is removed from tank and dried at 7, 14 and 28 days for testing. Draw the line on the specimens as displayed on the screen. Then, record the weight and dimension of the specimen. The specimen is placed longitudinally in the machine. A bearing strip made up of plywood is placed on both sides of the specimen and align it according to the marking. Sometimes, supplement bars are placed on top of the plywood depending upon the diameter of the specimen. Now, apply the load continuously at a rate within the range 1.2 to 2.4 MPa per minute. Finally, note down the load at which cylinder fails by developing cracks. The resultant split tensile strength is calculated by the equation 2P divided by phi into D into L, where P is equal to load at which the specimen breaks. Thank you for watching. Stay tuned. The best is yet to come.
Okay. So, again, summarize natin yun, class. So, supposedly, class, meron tayo nung letter C. Okay. This time, class, ito yung tension test natin. Okay. Yung tension test natin, class, it's specifically, ang specific test natin, class, is yung split tensile test. Split tensile strength test. Okay. So, ano yung specimen natin dito, class? So, cylinder tayo. Okay. So, cylinder class of, again, 150 mm diameter by 300 mm. Okay. So, matik na height na yun, no? Tapos, meron tayong formula, class. Ang formula natin for this one, T, or like yung tensile strength natin, class, equal to 2P over yung pi dl. Okay? Ganun lang po, simple lang natin. Tapos meron tayong D class. So yung D is yung rebound test natin. Okay? So technically class, surface hardness. I-edit ko na lang. Ganyan na. Okay? So, ito naman yun, class. Okay? So, dito lang, class, gagamit siya ng parang vibration or yung Schmidt hammer. Schmidt. Yung concrete test hammer. Okay? Yan. Parang ipapakita niya class mamaya. Tapos meron tayong formula, yung rebound number, tapos ano yung assessment natin dun sa rebound number. Okay? So, formula natin class, parang yung average lang ng 15 readings. Tapos yun, makalaman mo na kung ano yung quality ng concrete in terms of hardness. Okay?
Kindly do like, share, comment your views, and finally don't forget to subscribe our channel. Surface hardness methods.
Yan, so surface hardness pala yun. Kaya i-edit ko na lang din dito. Surface hardness. Okay? So tuloy natin.
Non-destructive surface hardness methods are non-invasive procedures that investigate strength characteristics of the concrete structure. This is generally done in any of two methods such as indentation methods and rebound methods. The rebound method is frequently applied to investigate concrete strength characteristics of concrete. This test was developed in the year 1948 by Swiss engineer Ernst Schmidt, and thus it is commonly referred as the Schmidt rebound hammer. The rebound hammer is a spring-controlled hammer that slides on a plunger within a tubular housing. The entire setup with their label is shown on the screen. When the plunger is pressed against the surface of the concrete, the mass rebounds from the plunger. It retracts against the force of the spring. The hammer impacts against the concrete and the spring control mass rebounds, taking the rider with it along the guide scale. The rider indicates the distance traveled by the mass, which is called the rebound number. The typical relationship between compressive strength and rebound number with hammer horizontal and vertical on a dry or wet surface of the concrete is shown on the screen. The value of rebound number is taken an average of 15 reading. The table shown on the screen shows the average rebound number and quality of concrete. There are many types of rebound hammer which varies considerably in performance, types of, and needs calibration for use on different types of concrete. This test can be conducted horizontally, vertically, or at an inclined angle. Thank you for watching. Stay tuned. The best is yet to come. Kindly.
Okay, so that's it, class. Again, summarize natin. So again, for this, for the third test class, na ginawa natin class ng surface hardness. So surface hardness test. Okay. So yung specific test natin class is yung same dito. Okay. Rebound hammer test. Rebound hammer test. Okay. So ito class, invented siya by yung the name itself class, no? Si Ernest. Nagkukulang, naghihirap ata sila sa ano nun. Vowel. Ernest. Schmidt. Schmidt. Yan. Engineer siya class. Okay. Tapos, yun. Okay. I-rebound yung hammer. Tapos meron tayong formula class. Supposedly, yung formula natin is para dun sa tinatawag nating rebound number. So, equal lang yan class dun sa sum. So, parang yung average ng 15 readings. So, sum of 15 readings, okay, divided by 15. Okay. So, yun na yun, class. So, dahil nag-stay tayo, right, meron tayo by x sa dulo, class. Okay. So, ito. Galawan natin kung paano manligaw. Okay. So, ang gagawin mo lang, sabihin mo kay crush, hi, crush. Tapos sabihin niya, huh? Tapos sabihin mo ng, I'm lost. I'm lost. So, wala siyang pakialam sa'yo. So, sabihin niya, Tagalog mo. Ligaw ako. Pwede mo ulit ng Pilipinas class. No? Okay. So, that's it, class, for Module 4. Thank you for staying. Goodbye. Good day.